Okay, today we'll be discussing about a memory concept. So what is memory? A memory is a very important thing which is required in order to design any embedded systems, right? A memory is an important part of the processor or a controller based embedded systems. Some of the processors or controllers contain a built-in memory and that is called as an on-chip, right? The memory will be already present on the single platform. So therefore that type of a memory is called as on-chip. And if you do not have support of using the memory on the chip, then obviously we need to go for a external memory. Then that type of a memory is called as an off chip, right? So this is the two type of a memory that you can go for it. It can be either an on chip or it can be an off chip. Also, some working memory is required for holding the data temporarily during the certain operations. So we'll be discussing what are the different types of a memories that we can use it for designing the complete embedded systems. So we'll be discussing. Of course, we all know that the memory is of two types. That is RAM and ROM. RAM is a random access memory, and ROM is read-only memory. So among ROM, we have many types like flash memory or the flash ROM, PROM, and masked ROM, and EPROM, NVRAM, and EEPROM. So these are the different types of memories which are available in the market. So based on the type of the applications or based on the type of the embedded systems that the user is defining, the person can choose the memory based on its requirements, which is suitable for its application. So first we'll be discussing about the MROM. MROM is also called as a masked ROM. Masked ROM is one-time programmable device. So what is meant by one-time programmable device? So whatever we are writing it on the ROM, if it is once it is written, we cannot erase it. So that is called as a one-time programmable device. And masked ROM makes use of a hardware technology for storing the data. So to store the data, we are using a specified technology called as hardwired. So the device is factory programmed by masking and metallization process at the time of a production itself, according to the data provided by the end user. So according to the requirement of the user, the information will be provided to the factory or the manufacturers, and the programming will be done by the company people itself. So that's why it is called one-time programmable device, or the hardware technology is the one we are using for it. And advantages, the low cost for the high volume production. So if we are going for the high volume production, then the cost will be reduced. So the limitation is inability to modify the device firmware against the firmware upgrades. So whenever if you want to upgrade your firmware, I mean to say that if you want to upgrade the software after some time, then there will be no possibility to modify it. So that is one of the major limitation. So since the MROM is permanent in bit storage, it is not possible to alter the bit information. So that is what once it is updated by the company people, it cannot be modified. That is one of the major limitation with respect to masked ROM. And the continuation of the masked ROM follows like this. The different mechanisms are used for masking the process of the ROM, like creation of an enhancement or the depletion mode transistor through the channel implant. So what we are discussing, what are all the different mechanisms that are available in order to masking in order to process the ROM. So one such mechanism is creation of the transistors. And what type of a transistors we are going with? We are going with enhancement or the depletion mode transistor. So what is enhancement transistor? So in the enhancement transistor, the channel will not be there. The channel has to be established, but in the depletion mode transistor, the channel will be already present between the drain and source. Okay, but we shall not go in depth about the transistor because it is out of the syllabus. By creating the memory cell either using a standard transistor or a high threshold transistor, in a high threshold mode, the supply voltage required to turn on the transistor is above the normal ROM IC operating voltage. So this ensures that the transistor is always off and the memory cell stores always logic 0. So these are the two mechanisms that are there in order to process the ROM. And we'll be discussing about a PROM. So PROM is also called as an OTP. So in the exam, they may ask, explain the PROM or OTP. So what is OTP? It is one-time programmable. Again, it is same as MROM. That is masked ROM. So it is a pre-programmed by the manufacturer. And again, the same story. So as we have seen with respect to the MROM, in the PROM also it is pre-programmed by the manufacturer itself. The end user is responsible for programming these devices. So this memory has a nichrome or a polysilicon wires arranged in the matrix. So whatever the matrix it is done right, or whatever the matrix that are used is arranged by, or this has been done by the nichrome or a polysilicon wires. So these wires can be functionally viewed as a fuses. So it is a programmed by the PROM programmer, which selectively burns the fuses according to the bit pattern. So fuses which is not blown is considered as a logic 1, and the fuse which is blown is considered as logic 0. So we'll be storing the information in the form of logic 1 or logic zeros. So if the fuse is blown means, just understand it is logic 0. If it is not blown means, then it is logic 1. So one-time programmable memory is widely used for the commercial production of an embedded system whose prototype versions are proven and the code is finalized. It is a low-cost solution for the commercial production. OTPs cannot be reprogrammed. So what is the difference between MROM and PROM is, so here it is arranged in the form of matrix, and all the matrix are done by the material called nichrome or a polysilicon wires. Okay, and again, if the fuses and those wires are considered as a fuses, and if the fuses are blown means it is considered as a logic 0. If it is not blown means it is considered as a logic 1. And again, everything will be programmed by the manufacturer, whose program is in turn supported, or it is provided from the user end itself. And again, this OTPs cannot be reprogrammed. Again, this is one of the disadvantage.